Hi everyone. This video we're going to be taking a look at a fairly long argument using indirect truth tables. We're going to be showing whether it's valid or not. So let's see how many propositions we have. We have A, we have not A actually, C, so that's 2, B, so that's 3, not E, so that's 4, and then B, A, and E we've seen this already, C we've seen this, and D. So we have 5 in total. If you remember our 2 to the L rule, so let's see, equals 2 to the 5th power. So we're going to have 32 lines in total if we did this the conventional way. Now doing this using indirect truth tables, we'd only take 2 lines. We'd only take the line writing all these out. If you write them horizontally, you can write them all in one line, and then the line under it assigning truth values. So again, we assume that the premises are false, and the premises are everything before this doubles line, and they're separated by this single forward slash line, and everything after the double forward slash line, which is usually like one thing, everything after that is the conclusion. So we're going to start this by assuming that the premises are true, so we're going to give the main operators a truth value of true. So right here, our main operator is a conditional, and I'm going to assign it a truth value of true. Right here, our main operator is the OR operator, so I'm going to assign it a truth value of true. If we go to our next operator, our next main operator is negation, so I'm going to assign it a truth value of true. If we go to our next premise, our main operator is conditional again, so I'm going to give it a truth value of true. And our next premise is also conditional, and I'm going to give it a truth value of true. And lastly, we have our conclusion, which I'm going to give a truth value of false. Now, if you remember, we have 5 propositions, which are A, B, C, D, and E. So some people like to do is they like to make a little table to line up all their propositions with their truth values. So I'm just going to do that. I'm going to write down A, B, C, D, and E right here. And above that, I'm just going to write statement for the statement. And then next to it, I'm going to write T-V's for truth values. And I'm just going to highlight these, I'll highlight them blue, just so we can differentiate them between what's below them. Now, so I have them right here, and I haven't written down any truth values yet, because we haven't gotten to any of them yet. We've actually have one already, which is D. So next to D, I'm going to write F, because that's our conclusion. So with that, let's start proving that, let's start showing this argument, seeing if it's valid or invalid. So our D right here is false. We can see right here D is false, so I have a D right here, so I'm going to write a false right here. And if this D is false, then the only way the conditional could be true is if C is false. So I'm going to write a false for C right here, and then a false for C right here. I'm also going to scan the argument for any other C's to also give that C a truth value of false. So we see that I have a C right here. I'm going to give this C a truth value of false. Now that I've given this C a truth value of false, I know that it can only be true if this has a truth value of false. Now since this is not A as opposed to just A, the negation gets a truth value of false, and therefore A gets a truth value of true. And so we get true right here. Now that we have A's truth value, we jump around looking for other A's. So we have an A right here, so A gets a truth value of true. If A gets a truth value of true, that means E also needs to get a truth value of true, because if E was false, we'd get a contradiction. So continuing with the assumptions, E gets a truth value of true. What else do we have? We have our B right here. B gets a truth value of false because it's being negated. So B gets a truth value of false. Now we've given everything. We've given just about everything in our argument a truth value except for this second proposition right here. And let's just assign that truth value. So right here we see that our B is false, and that means that our this negation has to be true, and that means that our E has to be false. But as you can clearly see right here, we put a false for our E in this premise, so I'll just highlight this red. And right here in this premise, we put truth value for our E being true in a different color. So I'll just use green for this. Green's actually kind of a bad color. Let's use this kind of bluish color. Which is also kind of bad, but that's fine. So as you can see right here for E, we had to put a truth value of false. Right here for the C, we put a truth value of true, and that's clearly a contradiction. So by proving that there's a contradiction here, we assumed that it was invalid, and since we assumed that it was invalid and we found a contradiction, that proves that the argument is valid. And if you wrote the argument horizontally, like as you can see, these two premises are written next to each other horizontally. If you wrote the whole argument like that, you could have done it in just 2 lines, which would save you a lot of space. So this is the huge advantage to using indirect truth tables. We didn't get the truth value for everything, and so we kind of missed out on that, but just on like the whole thing. But just if we really wanted to prove whether this argument is valid or not, indirect truth tables can't be beat. So thanks for watching, and in the next video we're going to be starting the next section, which is propositional logic, which is my personal favorite. So I hope to see you guys in the next section, and see you then.